Welcome to Pre-Algebra with Miss Betsy. Today we're going to be doing some work where we are solving word problems. We're learning more about how to write equations to solve those word problems, and today specifically we're going to be working with those situations when you have to deal with finding percentages in order to come up with the solution to your problem. If you're using the same text that I am in Pre-Algebra for Christian Schools. It's published by Bob Jones University Press. I'm using the first edition, and I'm in section 4 of chapter 10, and it's called Problem Solving Writing Equations. You don't have to use this text, but if you are tracking with me, I'm on page 323. Now for my lame joke for today. What does an elephant smell like after it takes a shower? It smells like a wet elephant. So, now those of you who haven't seen my videos before, you know the lamer the joke and the more groans that I can get, the happier I am. So I'm thinking that that one right there should have been pretty bad. Pretty bad groans. So what I've already written up in here, these are the 4 steps that our text uses to help you understand how to solve a word problem when you've got this strategy. They come up with fancy names that say, well, okay, what are you going to have to do? Well, in order to be able to solve a word problem, you have to write an equation. So all of a sudden, writing an equation becomes a strategy. Since we're working with word problems, we're finding something that we don't know what the answer is, so that's what they call the unknown. We're representing an unknown number with a variable, and that's what algebra is all about. Using a letter to represent the quantity that we don't know. So first we want to find, we're going to be representing an unknown number with a variable. Then if there are other conditions that they give to us in that word problem, we're going to write those, express those same conditions in terms of the variable that we've already selected and identified in our first step. And then of course if you're going to be creating an equation, for there to be an equation, you have to have 2 quantities that represent the same amount. You have to have 2 different quantities in the problem that are equal. And then once you know what those 2 different quantities are, then you can write and solve an equation. Because what we're working on in chapter 10 has a lot to do with percentages, expressing percentages as decimals, finding percentages of a number. A lot of our word problems in chapter 10, section 4, are going to deal with percentages. So let's just look at this first example here. And the question simply says, write an equation and solve. The cost of a small beverage is 60% of the cost of a large beverage. If the total cost for one small beverage and one large beverage is $1.52, what is the cost of a large beverage? So let's look back at our steps here. And the first thing that we want to do is represent an unknown number with the variable. So a lot of the times people just default to using X as the variable that you're going to use to represent an unknown quantity. Sometimes people like to put in like B for beverage, or C for cost, or S for the number of students. You can use any letter that you want to use. It's just a representation of this answer that you're trying to come up with. Doesn't matter what variable you use. Since some of you have the same text that I do, I'm going to go ahead and use B to be the variable that we're going to use to represent our unknown, because they're using that for beverage. So we have to figure out what in the world are we going to have B, what's our variable going to represent? So let's look back in our problem, see what we have. It says the cost of a small beverage is 60% of the cost of a large beverage. That sentence right there goes right back here to the second part of our process for coming up with an equation. Represent other conditions in terms of that variable or in terms of that unknown. The price of a small beverage is given with reference to the large beverage. It only costs 60% as much to get a small Coke as it does to get a large Coke. So, for example, if the large Coke costs $1, The small Coke is 60% of that price, or 60 cents. So that tells us that we're going to have our variable be the cost of the large beverage. Because we don't know what it is, what that cost is, but we do know the cost of a large drink. We do know that however much that large drink costs, a small drink only costs 60% of this. So how do you write 60% of B? Well, you remember that that is 60% can be written as a decimal, 0.06, 0.60. So if B is the cost of a large drink, then 0.60 times B is going to be the cost of a small drink. This part of our setup here to the problem is among the most important parts. It's one of the two most important parts. Actually going through and solving an equation, solving a word problem is pretty straightforward. What is the most challenging part to you is figuring out what your variable is going to represent, making sure that you represent other pieces of information in the problem in terms of that same variable. And that's what we've done now. We've said, okay, we don't know how much a large soft drink costs. So we're just going to say, let X be the cost of a soft drink. Well, here, let B be the cost of the beverage, because in our problem it talks about beverage. I have room to write drink, I don't have room to write beverage. And then we also saw in our problem that regardless of what the cost of the large drink actually was, the small drink always costs only 60% of this. So what we've done now is we have identified and labeled our initial variable, and other conditions that we have in that problem we have expressed in terms of that same variable. Now, step 3 says, identify what quantities in the problem are equal. And this is where you say, okay, if I do group these things together, this is what I'm going to come up with. So let's go ahead and look back at our book, look at our problem, and it says the total cost for one small beverage and a large beverage is $1.52. So then what two quantities do we have that are equal? Well, we have our little small drink here. Don't you just love my artistic ability? Our small drink plus the cost of a large drink, cost of a small drink, plus the cost of a large drink is equal to $1.52. So you're going to treat your friend to a drink. Maybe they don't drink as much as you do, so you buy them a little one, you buy you a big one, and it costs you $1.52. Now, do we have variable expressions that identify the cost of a small drink and the cost of a large drink? Well, yes, of course we do. It would be sort of a pointless problem here if we had not come up with expressions that represented these two different costs. The cost of a small drink is 0.60B times B plus B is equal to 1.52. Combine like terms, 1.60B is equal to 1.52. I don't care how much 1.6B is equal to. I need to know what 1B, just B by itself, is, because we want to find out the cost of a large drink. So in order to isolate the B, we're going to divide both sides of this equation by 1.60. You may use your calculator to go ahead and come up with that value. When you do your division, you see that B is equal to 0.95. Now we need to do more than just say 0.95 because this is a word problem that we're solving. What is B? It's the cost of a drink. So how's our cost here? What's this going to be? You have to put your dollar sign. And what exactly is B? Is this the cost of the big drink or the cost of the little drink? B is the cost of a large drink. So to fully complete this problem, you identify the units as dollars, and then you say that this is the cost of a large drink. Now, are we finished? We haven't said what the cost of a small drink is, have we? Well, do we need to say that? Refer back to our text. It says, if the total cost for a small beverage, for one small beverage and one large beverage is $1.52, what's the cost of a large beverage? Doesn't ask us how much a small drink costs. We can easily figure that out. If the total cost is $1.52, then the cost of the small drink is going to be what? 57 cents, I think. But that's extra information they didn't ask for. You don't need to solve it. But you did have to come up with this expression that represented the cost of a small drink, because that was necessary piece of information in order for you to come up with an equation to solve your problem. So this is an example of how you would use a strategy, write an equation to solve a word problem, one that specifically included a percentage in that problem. So let me go ahead and erase this, and we'll look at least one more problem. Word problems, when you're new to solving word problems, they can seem to be so very frustrating and an impossibility to solve that you just want to throw up your hands and say, I'm not going to even try them. Alternatively, though, sometimes when you watch the teacher go through a problem, you think, man, that makes perfect sense. I totally have this down completely. And then you get home and you figure out, okay, it was easy in class, it's not so easy now. Some of you will find word problems easier than others of you will, but all of you will need to take the time to sit down and work these problems on your own. These are things that the more you practice, the better you'll become at it, the easier it will be for you to identify what you want your x to be, how you want to represent the other conditions in your problem in terms of that same variable. It will become easier for you to set up the equation. And of course, the more that you practice, the easier it is to carry out the algebra behind the equation. So let's look at this next problem. This is in the skill check. It's problem number 1. The cost of a first class ticket is 150% of the cost of a coach ticket. If the total cost for one first class ticket and one coach ticket is $575, what is the cost of one coach ticket? Okay? Very, very similar to the problem that we solved the last time. We have, instead of 2 differently priced drinks, we have 2 differently priced tickets. The first class ticket, which is by far the nicer way to travel, I've traveled first class once, one leg in my life, or maybe twice. It was very nice. But first class here costs half again as much as it does to travel coach. So if we're going to represent an unknown number with a variable, that's the one that is at the very most basic part. That's what you're trying to find. So what are they asking? They say, what is the cost of a coach ticket? So let's just have our variable C be the cost of a coach ticket. That's what we're trying to find. That's what our variable will be. What other pieces of information do we have in this word problem? Well, if you look in here, you see that it says a first class ticket costs 150% the price of a coach. So this is where we have another condition in the variable. which is the cost of a first class ticket, it's being expressed in terms of the cost of a coach ticket. So what is 150%? You write 150% as a decimal, 1.50, that's 150%. Do you have to have that 0 at the end? No. 1.5 is 150%. 150% of the cost of a coach ticket is equal to the cost of a first class ticket. So now we have completed the first two steps of our algorithm, of our plan for how we're going to write an equation. We've represented an unknown expression with a variable, an unknown number. How much does a coach ticket cost? We don't know. We're just going to say it's C. We've taken other conditions in the problem, which is the cost of a first class ticket, and that is 150% the cost of a coach ticket. Now what we have to do is identify what quantities are equal. We go back into our problem and we read it, and it says total cost for one first class ticket and one coach ticket is $575. So the price of two tickets is equal to $575. So that's where we have our statement of two quantities in the problem that are equal. It's equal to 575. Combine like terms. 2.5C is equal to 575. We have the cost of a coach ticket, the cost of a first class ticket, and together that equals $575. What does our problem ask us to find? It says find the cost of a coach ticket. One coach ticket is just C by itself, so we're going to divide both sides of this equation by 2.5. When you complete this arithmetic, you see that the answer is, as I write it right off my book, C is equal to 230. 230 what? 230 bananas? What is C? We defined C to be the cost of a coach ticket. So $230 is the cost of a coach ticket. And you would identify this cost of a coach ticket. Now we could have calculated the cost of a first ticket, of a first class ticket. Matter of fact, it would be $345 because it's half again as much. But they didn't ask us to give to them the price of a first class ticket. They simply wanted the cost of a coach ticket. So that's all that you need to do to solve this type of problem. Let's do one more example. This is not a percentage problem, but it's just practice writing an equation. This is our second example in our skill check. Okay, right here, shameless plug for Chick-fil-A. Support them, they're a great company. Okay. Rusty has 4 fewer books than Sarah. Together, they have 50 books. How many books does Sarah have? Another way to help you know what the definition of your variable is going to be is to look at the problem, and it's going to be what they're asking you for. What's the question? How many books does Sarah have? So they use S for Sarah. I'll get totally mixed up with that. So I'm just going to say let X be the number of books Sarah has. Now, who else are we talking about in this problem? Well, we're talking about Rusty, and the problem tells us that Rusty has 4 fewer books than Sarah has. So let's say that Sarah has 10 books. How many books is Rusty going to have? Well, he's going to have 4 less. 10 minus 4 is 6. If Sarah has 7 books, Rusty has 4 fewer. 7 minus 4 is 3. So no matter how many books Sarah has, Rusty, no matter how many books Sarah has, X books, the number of books that Rusty has is always going to be 4 fewer books than the number of books that Sarah has, the total number she has. So this is where we come up with the second part of our procedure for writing an equation, where it says represent other conditions in your problem in terms of that same variable from step 1. Here we have X that represents to us the total number of books that Sarah has. We subtract 4 from the number of books that Sarah has. That gives us the total number of books that Rusty has. Number of books Rusty has. So now we have represented every condition that we have in this problem in terms of the same variable, and we want to look at our problem and see what 2 conditions do we have that we can set equal to one another. So let's see. It says, together they have 50 books. The number of books that Sarah has, which we don't know what it is, but we know it's represented by X, plus the number of books that Rusty has. You add those 2 quantities together, and together they have 50 books. Why did I put X minus 4 in parentheses? Because it's that expression together, taken as a whole, that represents the number of books that Rusty owns. If this had been, you subtract Rusty's books from Sarah's books, and that would be equal to 50, then this plus sign here would have been a subtraction. It would be important to make certain that you had that X minus 4 in parentheses, because if you didn't, it would change the problem. What are we going to do now? Going to remove the parentheses and combine like terms. X plus X is 2X, minus 4 is 50. We add a 4 to both sides of the equation. 2X is equal to 54. X is equal to 27. 27 what? X is 27 books, the number of books that Sarah has. 27 books. That Sarah has. So how many books does Rusty have? As I put a question mark at the end of this statement here because I was asking you a question. Sarah has 27 books. 27 minus 4 is 23. Books that Rusty has, 23 plus 27 gives us 50 books. But your problem did not ask for that. So 23 plus 27, even though that's the answer, it's only asking you for 27 books, which is how many Sarah has. So that's the end of this problem. Thank you. We'll see you next time.